let's now have a look at the parametrics for the hyperbola. So I've just drawn one branch in. It also has to do with the auxiliary circle. There's the auxiliary circle. Now, how on earth do we get the angle that we're going to refer to in the parameter? It's an interesting way. What we do from P, we drop a vertical down. From the point of intersection there at the x-axis, we draw a tangent, and then we create the auxiliary angle at the centre, the radius being perpendicular to the tangent. So it's an interesting way we create the angle with that one, but that's how the hyperbola relates to the auxiliary angle. Now, using that, we should be able to get some coordinates. The x value would just be the hypotenuse of that right angle triangle. So x over a would be the secant of theta. So x is a sec theta. And then the y value, well, I'm just going to substitute it in. It's sort of, it's not a fudge really, but I mean, we know it has to satisfy the equation of the hyperbola. So if I sub it in, we can get the y value for the parameter. So we end up with y is b tan theta. B tan theta. So there's our coordinates, a sec theta, b tan theta. I won't bother deriving the whole things again. I mean, it's the same process as we did with the ellipse, and we see similar things happening. The tangent, once again, will mimic the equation. So we get x1x a squared minus y1 y b on b squared is 1. The normal, similar thing happens again. Right? The a squared and the x1 flip. The b squared and the y1 flip. And the negative changes to a positive, because we're talking negative inverse. Notice, it's interesting, we get a squared plus b squared, but of course, for a hyperbola, that's still the focus squared. So it's the same as the normal for the tangent. We get a squared, e squared there. And using parametrics, if we were to sub in those parameters, we'd end up with x sec theta on a minus y tan theta on b is 1. And the normal, there it is, ax on sec theta plus by on tan theta again is equal to a squared plus b squared, or if you prefer, the focus squared, a squared e squared. If you are deriving it from parametric form, we haven't really talked about differentiating sec yet. If you differentiate sec, you get sec tan. So differentiate sec, you get sec tan. We could prove that by, I guess, changing sec to 1 on cos and then differentiating that. The other, or tan, we know how to differentiate. That goes to sec squared. So if we were going to differentiate the parameters, that's what we'd need. Quarter contact, once again, it will mimic the equation, so it will become x naught x on a squared minus y naught y on b squared is equal to 1. Oh, wasn't that a quick little bit of theory for today? Done.